Hello everyone. This is the team lead from Team New Monks, Tanmay Shetty, here to present our solution to our problem statement, which is with the ID 25040, which tells us to build a conversational AI platform to make the oceanographic data, which is produced in a very uh, difficult format, netcdf format, accessible to everyone. And this is the demo of the product that we have come up with. So as you can see, we have showed you, you can see that we are coming up with a solution that allows users to give a query in natural simple English, and the backend, which contains an LLM and RAG pipeline, converts the simple English query into an SQL query and runs it against a database and produces an output, and also visualizes the output in a very readable format into maps and graphs, and also shows the raw data to the user. The netcdf format data that we have used is obviously taken from the INCOIS website, which is the government website where and the data is produced by the floats. Just to mention that there are around 4,000 autonomous floats worldwide, which gives us 100,000 uh, salinity temperature data every year. To show the first feature of our product, it is the chatbot. This is the main feature of our product. As you can see, the first example, we will be giving a query as to show the floats across the Arabian Sea during 2023. The chatbot gives us an output telling us that there is no matching data found for the query, and try broadening the filters. And the second example is list profiles between 10 to 20 degree north and 60 80 degree east, and we actually get an output which is in a raw table format and also a graph format. So what we are trying to show is that we have grounded our LLM with the RAG model, such that the LLM does not hallucinate and produce us with wrong data and guesses the data. Instead, if the data is not produced in a given data set, it gives us an output saying that there is no data for your query, try broadening the filters. And when an actual proper query is given to the LLM, it produces us with an proper required output. So to explain a little bit about the tech stack that we have used, the netcdf data that is being ingested by an ETL pipeline, first we clean that data using Python libraries such as xarray and numpy and pandas. After we clean the data, we store it in a database, SQL database, and we are using PostgreSQL and with a PostGIS extension. The PostGIS extension is used for geospatial queries such as the Arabian Sea or the Bay of Bengal, such queries. And the other part in our backend is an RAG system, an RAG pipeline, which is connected to a vector database, and we are using ChromaDB for our vector database. The vector database stores the metadata of common queries such as English words. Could be something like the name of months, which tells the LLM that if the month range is from November to February, then it has to search. If the query is something like give me the temperature in the winter season or in the summer season, the LLM understands that winter season has to be converted and checked across the SQL for months ranging from December to or November to February. This is done by the vector database. And after this, the RAG pipeline uses the context retrieved from the vector database and the natural language query that the user has already given, and gives and prompt to the LLM agent to produce a SQL query. And the LLM agent runs the SQL query against our database to produce an output. And uh, as of now, we are using a localized LLM agent, Llama 3. That's it for the tech stack, and we have used React for the front end. To continue with the demo of our prototype, next, we will be showing the visualization part that we have implemented in our product. So as you can see, there are different things, different possibilities. Here we have showing the graph and also a few details. In the first, we can choose the region as different regions from Arabian Sea, Bay of Bengal, etc. Then we can also choose a time range, could be 3 months, 5 years, a month, or other things. And a float produces data for 2000 meters, so we can also choose the range of the depth from where we want the data from. And after we press on show animation, we can see the different types of graphs that are being produced for the temperature, salinity, and the float network shows us the different floats and the location of these floats on an interactive map. And we have made a different map tab for this, and this one's a temperature anomaly detection, and plotted in a graph according to the years. Next, the map part will be shown. So here we have made a different tab for the interactive map. We have integrated a lot of features into this map. As you can see, we can change it to an OpenStreetMap, a satellite view, or an ocean-based map, terrain view, dark view, or even a watercolor view. And this map shows us the actual location of the floats. And also, when we zoom in, it displays the data, and when we zoom out, it displays only the required data, such which and thus helps in maintaining the sustainability of the model. Where other live stats such as the number of active floats, the average temperature, the total network, and all of this is real-time data that is being shown. And on the left side, as you can see, there is the number of active floats, salinity, data points today. Recent activity shows us that there are 3 floats. The data was taken 2 minutes ago, an hour ago, 3 hours ago. And also the color is also an indication. The orange color says that the float is under maintenance, and the green color says that the float is currently active. And finally, we have also implemented an heat map into this interactive map design. As you can see, when we turn on the toggle switch, and heat map is in front of us, showing us the different floats also. And this is the map section of our prototype. Next, I will be showing the authentication page slash the login page, and there are 4 different types of login. Could be marine research, fisherman, policymaker, or a maritime operator. It requires an email address and a password like any other authentication page, or you can also create an account which takes in a few required details like your organization, country, and username and password. And that's also. And finally, we also have integrated uh, interactive dashboard. The dashboard shows us a few data such as the active floats, the last update coverage. The main part, the very interesting part is the feature that we allow to add widgets into the dashboard. As you can see, you can add a temperature, salinity, network analysis, the different types of graphs into the dashboard. And yes, as you can see, the different graphs have been added to the dashboard, and these graphs can also be moved and adjusted according to the user basis, and it automatically gets aligned with the page and can be expanded or collapsed based on the user requirements. The front end design has been done very clean, in a very clean fashion and an interactive fashion, such that the users stay hooked on to our product. And we are providing with different solutions so that it is useful to everyone. And I just want to explain a few problems that could possibly be with our solution and how we aim to achieve the solutions for those problems. The first one would be a trust issue, where the also either also even though we are grounding our LLM agent with an RAG model, but the SQL query generated could be hallucinated, and the LLM could generate wrong data queries, SQL queries, such as creating rows, etc. And to stop this, what we are planning on doing is not a black box AI, but a glass AI, such that the LLM is allowed. We have put constraints on the LLM to generate the SQL queries. The LLM can only generate select and where clauses, and will not be able to generate any DDL or DML database queries, such that allowing the LLM to not produce any fake data. Also, a rule based. Our future plan is next phase is to implement a rule based agent that checks for the syntax of the SQL query generated, the possible errors, the possible context the SQL query is generated in order to minimize the errors. And also, this SQL query generated will be shown to the user to provide a transparency between the user and the LLM such that the trust is built. And another problem is the quality of the data. The data produced by the floats, even though we are taking it from the government portal, could be wrong data. So a quality control flags could be added such that 0 to 4 is 0 indicating the best data, 4 indicating the worst data. And the our LLM agent will only use data that has been marked as 0, 1, 2, or 3 to produce an output to the user without taking 4 data marked as 4 into consideration, allowing the users to get the best possible output. So these are a few problems that we are trying to address along with the main prototype that we have already built. This prototype is still in our first phase, and very much think we have to add a few more features and make this prototype a better one. Thank you.